Hey Math 20-1 students, we're looking at lesson 4.4, the quadratic formula. So we've actually looked at the quadratic formula in the radicals unit before, but we're going to come back to it. So this is that formula that we've already seen. It's on your formula sheet. So there's never any memorizing with this, but I wanted to show you how this was created. So it started by taking the standard form and actually completing the square for it. So I want to show you how to prove this right here. So step one, whenever we're trying to complete the square and do the process of changing it to vertex form and then solving from there, we always start by putting brackets around our x values. And then we're going to take that a value and divide it from both terms. So that's going to go in front. So you're going to be left with x squared plus b over ax. We're going to leave some space plus c equals 0. Then you always take half of that number, which is going to be equal to half of it is b over 2a. And then we're going to square that, and that's going to be b squared over 4a squared. So that's what squaring the actual number is. So we're going to add that squared and half number, and then we're going to subtract it right away. Now we're always going to take this number, this negative number outside, but we're going to have to multiply it by the value in front, which is our a, our stretch. And then to factor this, we're always going to take half the middle and square it. So that's going to be half of that number, or sorry, we don't have to square it, just half of that number is going to be b over 2a squared outside, and that is equal to, when we divide out the number of a, we're going to get, minus b squared over 4a cubed plus c equals 0. That's a mistake, guys. Okay, so what I should have done, let me go back here. I should have multiplied by a. When you multiply, it goes to the top of the fraction, so it should be b squared a over 4a squared plus c. Now, that's better. The reason I do that is because now I can simplify these. So whenever I have an a at the top, a at the bottom, I can actually cross one set of them off. So I'll show you what I mean. So that's going to be b squared over a, or times a, and then 4aa, and these guys will cross off because they're identical. When you divide the same number at the top and bottom, they become 1. So we have b squared over 4a plus c equals 0. Our next step is to join these by getting common denominators. So we're going to have b squared over 4a, and then we're going to go multiply the bottom and the top of that fraction, because right now there's a 1, even if you don't see it underneath the c. So we're going to get common denominators by multiplying the top by 4a, and then the c still stays there, and the bottom by 4a. And then these are common, so you join them together by keeping the common denominator. And the tops you just add together. So you add them over a common denominator of 4a, and that should still equal 0. What we're going to do now is we're going to bring this to the other side of the equation. The left side stays the same, but on the right side you should have b squared, positive b squared, plus 4ac divided by 4a. Now we're going to divide both sides by a, which means that it goes to the bottom of the fraction. So anytime you divide, it goes to the bottom. Anytime you multiply, it goes to the top of a fraction. And now we're going to square root both sides, because right now we have this squared value. So if we square root both sides, it'll bring it to the other side. So we're going to square root this whole thing. and that a squared at the bottom becomes just a squared. So now these guys cross each other off, leaving me with x plus b over 2a equals, the top we can't really do anything with it, so we're going to leave it as b squared minus 4ac, but the bottom, the square root of 4 is 2, the square root of a squared is a. And second last is you're going to bring this guy over to the other side to get x by itself. Isolate for x. That'll give you minus b over 2a. And whenever you square root something, remember you're going to have to do positive and negative, and that's where this guy comes from. So you're going to have positive, negative, square root, the top only, b squared minus 4ac, divide that bottom by 2a. As you can see, they have common denominators, so you can write it as one common denominator. So that's why the entire top is divided all by 2a, and there is our quadratic equation. Okay, so it's just steps that you want to be familiar with. Just we want to understand why we use something and not just use it and ignore that there's a reason that this is all coming into play. So we're going to apply the quadratic formula to these. So if you remember back in the radicals unit, we started by labeling. If you have your equation in standard form, it looks like this. A is always the number in front of x squared, so that would be in our case 1. B is the number in front of x, so that's going to be positive 3. And C is the constant, which is negative 2. So don't forget to include the signs. Then we're going to put it into that equation. Negative b plus minus square root of b squared minus 4ac divided all by 2 times a. And that equals negative 3 plus minus. And then we'll have 9 plus 8. So in your calculator, double check. You just want to go 3 squared. Make sure you put brackets just like I did. 3 squared. Now the important thing is to always keep brackets exactly the way I do it, and then you're likely to get the right answer. You should get 17 here. Divide the answer by 2 times 1, which is 2. We're going to solve this. We're going to get the answer. So we're going to put both the positive and the negative in our calculator. So you're going to go negative 3 plus the square root of 17. You're going to get the answer, and then you're going to divide the answer by 2 to get 0.56. So that's one x-intercept. The quadratic formula gives you where the graph touches the x-axis. So that's called a root, or a 0, or an x-intercept. They mean the exact same thing. So now we're going to go negative 3 subtract square root of 17, and then we're going to divide that answer also by 2 to get negative 3.56. So there are 2 x-intercepts, 2 answers to this. So that's our first one. We're going to repeat all these steps for all these examples. So when we do this, we always want to make sure one of the sides equals 0, so bring stuff over. A equals 2, B equals negative 5, and C equals 2. So in our formula, x equals negative b plus minus square root of positive b squared, so it's just b squared, minus 4ac. Divide the whole thing by 2 times a, which is 2. 2 negatives becomes a positive, so you need to write that. And underneath the square root, we're going to have to go negative 5 squared is 25 minus 4 times 2 times 2. We get positive 9. Divide that whole answer by 4. That means that you're going to have 5 plus minus 3 divided by 4, because the square root of 9 is 3. So our 2 answers are going to be where you go 5 plus 3 and divide it by 2, so that's 4. And where you go 5 minus 3, divide that by 4 as well. And you get 1/2. So those are our 2 x-intercepts. You can always graph this and check that you get the exact same values for the x-intercepts as well. So you can always double check your answer by doing if you can factor it sometimes, that would be a possibility in this case, or you can graph it to see where it touches the x-axis. So those are important things to remember when that there's not just one method anymore. C, our A is 1, our B is -5, and our C is 7. So we want to go x equals -b plus minus square root of b squared minus 4ac divided all by 2 times a. And then we're going to simplify. The two negatives becomes +5, and then we have 25 again. Subtract 4 times 1 times 7. And you should get -3 here. Now I actually don't have to go further. The reason being is we're not allowed to square root a negative. So we're not allowed to square root a negative number, which means that there are no solutions. The graph is not going to touch the x-axis in this case, so no solutions will occur. And then we can move on to the next one. So as you can see in A and B, we had two different solutions for the x-intercepts. Our solutions, there was two solutions, but in this case here we have no solutions. Our next one here, we have A is equal to 1, B is equal to -6, and C equals 9. So in our equation, x equals -b plus minus square root of -6 squared minus 4 times 1 times 9 divided by 2 times 1. 2 negatives becomes +6, and then we have 36 minus 36 over 2. Now, whenever we have 36 minus 36, we're going to write square root of 0. Square root of 0 is 0, so we're going to have plus minus 0 over 2, which we can ignore. So our solution is going to be 6 over 2, and that means we only have one x-intercept. Our answer is 3, and that's it. That means the parabola only touches the x-axis at the vertex, no other time. So those are the three possibilities. And so that takes us to our next idea, which is determining the nature of the roots. Another name for this is called the discriminant. So if they ever ask you for the nature of the roots, well, that means when are we going to have two solutions? When is the graph going to go through the x-axis twice? When is it going to go through once? And when is it not going to go through the graph and not touch the x-axis, which means that there are no roots, no solutions? Well, what we just found in our previous case is this discriminant value is going to be this b squared minus 4ac, which if you go to the actual formula, the discriminant is just this part. If you can figure out what this is going to do, then that tells you how many solutions are possible here. So for example, if b squared minus 4ac is greater than 0, that means it's positive. So if you ever get a positive number underneath the square root, you're going to have two different solutions, two different roots, two different answers for x-intercepts. If you find that the b squared minus 4ac in our last case was equal to 0, you're going to have only one solution. And finally, if b squared minus 4ac is less than 0, meaning it's negative, you're going to have that there is no solutions. It should not touch the x-axis at all. So the discriminant, what it tells you is how many solutions are there. That's what it tells us. So in this case, we're not trying to solve for the actual answer. We just want to know how many solutions there are. So we're going to use the discriminant value, which is this part. So in each of these, we are only filling out this equation. So our b in this case is 6. So you're going to go 6 squared minus 4 times your a is 2 and your c is 5. If you put that into your calculator, you should get that that is negative 4. So that's 36 minus 40. So by getting negative 4, we know that the d value, the discriminant, is less than 0, meaning it's negative. So that means there are no roots, meaning no solutions. Here, b squared, there is no b, because here a is equal to 1, and b is equal to 0, because there is none, and c is equal to negative 7, our constant. So b is equal to 0. So 0 squared minus 4 times 1 times negative 7, which means that our answer is negative 28. Oh, yes. Okay, so since, oh, actually positive 28. That's what I want to change. So positive 28. Now, since our value is greater than 0, that means there's going to be 2 solutions, 2 roots. And finally, our last case, b is equal to negative 12. We have to always put brackets around it. Our a is 4 and our c is 9. That means 144 minus 16 times 9 is going to also be 144. And so if you put that in your calculator, you get 0. So if d is equal to 0, that means there is 1 root, 1 solution. So that's what the discriminant tells us. Example number 3, they want equal roots, which means that there's only 1 root. That's another way of saying 1 root, if they're equal roots. Same answers. That means when our discriminant is equal to 0. So b squared minus 4ac is equal to 0. So what they're telling us is that our b value here is k. Our a is 1, and our c is equal to 4. So when we fill in this equation, b is k, a is 1, and c is 4. Let's solve for k. So we are going to get k squared minus 16. And if we bring that 16 over, we get positive 16 equals k squared, and then we're going to have to square root it. So k can equal positive or negative 4. So what that tells us is that whenever k is positive or negative 4, we're going to get 0. Where our discriminant is 0, and that means that there is only 1 solution. Our next 2 cases is we're going to have to do something called like trial and error. Or we call this a number line. We're going to use the number line method. So we already know that when k is negative 4 on the number line or positive 4 on the number line, we know that that's where there's going to be 1 solution. Well, we want to figure out when either in between here or on the outskirts is the k value going to give us 2 solutions and then no solutions, because it's kind of going to be in the either in the middle section or in the outside. So we're going to do something called trial and error. We're going to fill in, well, what if our k is equal to 0, because that is in between. So if k is 0, let's see what happens. So we're going to go, we know that the graph, in this case, we're going to solve for it. 0 equals 0 squared, so we're filling in k with 0. All the other letters and numbers stay the same. So 0 squared is equal to 0, and then we have minus 16. So if we solve for that, if we put that into our equation, we know that we're going to get negative 16. So as you can see, that in between section, we're going to get a negative answer. Okay, so when we fill in our k as 0, we get a negative solution. So if we solve this, if we solve for the other side, so I don't really need this here, we're actually solving for it and we get negative 16 is our value. Now, whenever we get a negative value, that is when there is no roots. So what we can do is write the answer like this. This in-between area right here, from negative 4 to positive 4 right here, that's when we're going to have no real roots because we're going to get a negative answer for all values. So what you're going to do is you're going to say when k is greater than -4 but less than 4, and that represents the in-between section, that's going to be where you get a negative answer, and that's no solutions. The last trial thing that we're going to do, now remember, you can always pause this if you missed that and go back and fill in your notes, but the last thing we need to do is figure out on the number line, if we already know that the middle section is for no real roots, that means that this part right here and here are for the 2 distinct real roots, and I'll prove that. What I'm going to do is I'm going to pick a value less than -4, for example, -6. I'm going to use that for my k value, so that's my b value, squared minus 4a, which is 1, and c, which is 4. So I know that's 36 minus 16. If you guys put that into your calculator, you're going to get 20. So 20 is a positive number, which means that there are 2 real roots, so that works. So when, in this example, when k is less than -4, we're going to get positive solutions. And finally, we're going to check the positive 6 value. 6 squared minus 4 times 1 times 4, so a number greater than 4. We get 36 again minus 16, which is also 20. So that's when k is greater than 4. So this is our answer for when we want 2 distinct real roots. So this is a standard of excellence question. It's a harder type of question because it's very hypothetical, and there's a lot of this when it comes into 30-1, so that's why I put this into the lesson. Our last example is similar to what we did in our completing the square and our factoring lesson, where we have a picture measuring 30 centimeters by 21 centimeters. What you're going to do is crop the picture by removing the same width from the top and the bottom and one side of the picture. So what we're removing is this X, this unknown width. So what we want to do is create an area of this new frame, this new picture after it's been cropped. Well, for example, 21, that is we're reducing that side by 2 x's because we're cutting off an x from the top and bottom, so we're going to have to go 21 minus 2x. This is going to be our width, our new width. Our length is going to be 30, subtract just one of the sides has been taken off of the 30, so we're just subtracting 1x. And then what they're doing is they're saying that this original area, which we're going to calculate by putting 30 times 21 in our calculator, we get 630, and that's centimeters squared. It's going to reduce the area by 40%. So we're going to multiply this by 0.40. So we divide this by 100, and that gives us 0.40, and we're multiplying that original area by it, and that's going to give us our new area to use for the cropped picture, which is 252. And now all we have to do is simplify this, get it into our standard form, and then we can use the quadratic equation. So firstly, let's do FOIL. 21 times 30 we already know is 360, and then we have minus 21x minus 60x, and then plus 2x squared equals 252. Now we're going to combine the like terms. These guys go together, and these guys go together. So we're going to have it 2x squared minus 81x, and then you're going to have positive 630 subtract 252 because we want 0 on one of the sides. And then 630 take away 252 gives us 378. So positive 378 equals 0. Now we know our A is equal to 2, our B is equal to negative 81, and C is equal to 378. And now we're going to use the quadratic equation, or quadratic formula. So negative b plus minus square root of b squared minus 4ac divided by 2 times a. So that's going to give us positive 81 plus minus. You're going to put that all into your calculator. So I'm going to do that right now as well. So I'm just putting the radicand in my calculator, and I get the square root of 3537 over 2 times 2, which is 4. Then lastly, I'm going to put 81 plus the square root of 3537. Divide that answer by 4. I get 35.12. Now this is centimeters that's being cut off. Now we can't use this because this is more than 21 centimeters and more than the other side. How can we cut off more than we actually have? So we can't crop the picture by taking off 35.12 centimeters from any side. So that doesn't make sense. Our next answer will be 81 subtract the square root of 3,537. Get your answer and divide your answer by 4. And you should get 5.38 centimeters, and that makes more sense. So this seems to be that determine the width of the removed strip. This is the width of the removed strip. And so that is how we solve our question using quadratic formulas. Okay, so that's it for our unit. So this was our lesson 4.4 using the quadratic equation. So what you want to remember from this is how to use the equation. The x equals minus b plus minus square root of b squared minus 4ac divided by 2a. And you also want to remember what the discriminant is and how to use it. Okay, so that's it.